uh, very proud that such a good number of presentations done and a lot of work has been done in this, and especially for the young researchers. As we know that in the last few years, the word blue economy has been coined several places. So I thought this would be a good topic to talk to you about my views on this. Actually, the blue economy is basically the economic activity which is dependent on ocean. But there are three more issues that we also need, that it should be inclusive. That means inclusive of a social development, also ensuring the environmental and ecological security. So this is what we want, is that since we know that the economic development has led to degradation of the environment, and that is why we need, when we are planning the ocean-dependent economy, we have to be very, very careful that we don't disturb or do minimal damage to environment and ecology. But at the same time, we continue to grow, improve the quality of life of people, and do the inclusive social development. So this was the basic concept, and this was first time introduced by Professor Gunter Pauli in UN, essentially in the view of the climate change, that because of the climate change, we may have to depend more on the ocean in the coming years. And then subsequently, the third World Summit, the UN SDGs, and the Blue Economy Summit, which happened in Nairobi in 2018, all supported this idea, and India is committed to the blue economy. Now, there are several issues which we need to address. The fisheries and ecosystem, minerals, energy resources, marine spatial planning. In India, we also called as a coastal regulation zone, water quality, hazards, and the response mechanism. There are several international laws and the treaty, those we need to understand, shipping industries, manufacturing industries, security and strategic dimensions, and how we develop the accounting framework, that whatever the economic benefit is coming out from the ocean, that accounting framework currently is not available. So we need to build that also, and to build overall policy, which Ministry of Earth Science is now engaged in developing this policy. Today, I'm not going to talk about all this. I will pick up only the four topics briefly, considering the time what we have available. Now, the first is the minerals. We have plenty of placer minerals, both on the beach and nearer to the shore, up to 100 meters, especially along the Kerala, Tamil Nadu, Andhra, Orissa, and Maharashtra. And these minerals are basically ilmenite, rutile, kyanite, garnet, zircon, monazite, and especially ilmenite is one of the largest reserves, about 22% of the world reserves. Now, currently on the beach side, there is some mining going on, but on the ocean, which is near shore, there have been identified blocks 5 minutes by 5 minutes by Ministry of Mines. However, there is not much development is happening because of a variety of reasons. There are many issues, but we have not been able to exploit these resources yet. And the total value of these resources is about 150 billion. So it's a huge resource. And we have all the technology for mining, for beneficiation, everything is available. So this is one area which we need to address and see that how we can develop this sector. Second, of course, the deep sea minerals. polymetallic nodules. We know all about this. Last 2 decades, a lot of work has been done. India has about 75,000 square kilometer in Central Indian Ocean. And now the first mining site of 12.5 meter by 12.5 kilometer has been also identified. All the work related to environment, beneficiation, everything has been done. The total value of this resource is 187 billion. So it's a quite huge resource which we have. Now, the next stage we will come that the certain technologies are to be developed. The other polymetallic sulfides, which is mid-oceanic ridges, which currently the exploration work is going on. And I understand that some of the vents have been identified and the detailed analysis of the rocks and all those things is undergoing, especially in NCPOR. And this is very important for the availability of a copper, lead, zinc, but more important, there is a gold, silver, palladium, platinum also is available. So this is another area which is very important. And we have about 10,000 square kilometer area which is to be explored. It may take some time to completely explore and find out how much resources is available. But the initial indications are very positive. The cobalt is one which is a very critical mineral in high-tech industries, and India do not have resources on land. And they have located almost 2 decades back a resource on Central Indian Ocean. Still, the exploration rights are yet to be taken, but I'm sure that in coming years, we would be taking up. So if you can see that we are going very systematically, we have tried to explore the areas and where we have some positive, we have gone right up to developing the mining site. The exploration for the polymetallic sulfide is going on, and for the ferromagnesium crust will be taken up in near future. The third issue is about the energy, especially the ocean-related energy, offshore wind, which has a tremendous potential, and is about 61 gigawatts on Gujarat and Tamil Nadu coast. There was a proposal for 1,000 megawatt offshore wind farm in Gujarat coast. However, I understand now there is some likely to be shifted maybe to Tamil Nadu. Current cost is about 10 rupees, which is quite high, but I'm sure that with the development of technology and this will further reduce. The major issue in developing offshore wind farms is you need a very specialized kind of an infrastructure. You need a very custom-built vessels. You need a port where there is a special facilities to take the turbine to the sites and then service them and several other things. So this is also very critical. The developing farm alone is not going to resolve the issue. We also need very specialized infrastructure on the port. And that is why currently this total cost of building infrastructure and all is relatively high. So there are certain issues which we need to address. I'm sure in coming years, we would be able to address them. The wave and energy, there are experiments done, but the issue is how we can scale it up. The ocean current has a tremendous scope because you can generate large amount of energy from this. But here, the major issue is the turbine. We need to build a turbine which can be used to take of this ocean currents. Thermal energy is another very huge resource, but it is still under experimental stage. We need to learn many things before we would be able to generate. But otherwise, it's a huge resource. I mean, the resource is so high that all our energy needs can be satisfied by this. Now, this is some of the technologies which is being developed by NIOT. And the first thing which is required is that you need to understand the seabed characteristics. So based on that, you can design your mining equipment. So the soil tester, which can measure all kinds of properties of the soil, its strength and many other properties, is been developed, tested right up to 6,000 meters. So this is one of the major achievement, I would say, that this could be done in a time completely indigenously. The second, which is very important development, is the remotely operable vehicle, which also can go up to right up to 6,000 meters. It is kind of a satellite which has can take a payload of 150 kg, and you can measure all the properties, whatever you need. And it has arms, you can collect the samples. And this also has been tested up to 6,000 meters. And the mining equipment, what we call as a crawler, is also has been developed. And this will collect the nodules and make it slurry and give it up to, push it up to the ship. And this, I understand that will be tested in 6,000 meters this season. So basically, we are now ready with the all technologies. Of course, when actual mining starts, you will have to scale it up. You have to collaborate with the industry to make such equipment in many numbers. Also, there are many other issues of bringing those material back to, or you develop a platform and process there itself. So there are issues, but I'm sure that in next 10 years or so, we would master all these aspects. Water is one of the most important aspects, and India has developed this an IoT, the low temperature thermal desalination, is one of the classic example of the innovation which has been done by India. This works on a very simple principle. They taken the water, saline water from the surface, which would be about 22 to 24 degrees centigrade temperature, and brought to the vacuum chamber. It boils and evaporates. The vapor is collected in another chamber, and it is cooled down by bringing water from about 800 meters or so. And you get a fresh water. It's a very simple physics in this, but the engineering is very critical. And India has 6 plants now on Lakshadweep Islands, and the Agati plant has been working for last 15 years. So this is really an operational, and the important part that's completely changed the life of the Lakshadweep Islanders. Their health issue has been resolved. There were a lot of issues about stomach-related ailments because the water they were having was dirty, and so this now has dramatically improved that. Similar principle is now being tried for the power plants, and also ultimately we need to scale it up to 10 million liters on ocean-based plant, which also the work is undergoing. So I think this is a kind of a thing which is India has developed this technology and shown that how it could be really useful. And this is environmentally very friendly, unlike RO, which releases very highly saline bitten into the west into the sea, while this is not, this uses only about 8 to 10% water. So whatever is released is more or less the same kind. Coming to the living resources, what we need to do is we need to build models. There is some work is being done in CMLRE that how we would be able to predict the stock of the fishery annually, every year after the year, like what we do in a crop. And this, of course, there's a very complex process to understand the physical and biological interactions. And this maybe for different species would be quite different. So we need to do this. And I'm sure that if we can do, then we can plan our fishing strategy that whatever the kind of potential available for particular area in a particular time, accordingly we can decide that fishing, how much fishing should be allowed. So this is another major area which is work is being done. There was a lot of mention about the climate change, and there is a definite shift which has been seen, especially in oil sardine and mackerel. These were the majorly earlier available on Kerala and Karnataka coast. But after 1985, it has been seen that the Kerala and Karnataka do not have that much catch of the sardine and mackerel, but at the same time, the catch has increased in Goa and Maharashtra, as well as on the east coast, both Andhra and Tamil Nadu. Now, this is very important because as the further climate or ocean warming takes place, this kind of fishery, which is one of the most important fishery of India, can dramatically change. Actually, last year, the Maharashtra has a bumper catch of the sardine. So many times this low catch on Kerala and Karnataka was considered because the overfishing, but it's not that. I think that there is a change is happening. And I think there may be many other species, there could be many such changes. So we need to look into these aspects also. The algal bloom is another major area which can affect the fisheries. And it's very nice that the system for algal bloom monitoring and the informing the fisherman and the all other concerned that when it is likely to happen, when it is likely to grow, and when it is likely to decay. So this is another very important from the economic point of view, which service has been developed. There is a lot of work done by CMLRE on the deep sea fishery, and large amount of resources have been found, especially at the depth right up to 2,000 meters. Of course, to harness this resource, you need a lot of new technology and processing, and the vessels would be needed. But there is a huge amount of resources available. The current estimate is about 3.3 million tons, which is more or less same as what we are catching today, about 3.6 million tons. So this is a huge resource is available. Also, there is a lot of experiments in the ornamental fishery on the Lakshadweep island, very successfully done. And I'm sure that it also provided a lot of employment to women on the island. So this is one, I think we need to further scale it up. Similarly, the open sea cages growing cobia and milkfish has been very well successful. Again, here we need to further scale it up to a level where fishermen can regularly use this. The CMFRI has now been doing black lip pearl. They have understood the complete life cycle in the lab. I'm sure that in coming years, we would be able to operationalize this technology also. And I think we need not have to restrict ourselves only to the Indian water. In Antarctica also, the krill is one of the very huge resource, and India is not currently utilizing its share in the krill. And I think in coming years we should do. It has very important because this is a omega B, this major comes from the krill. So this also is another area which we need to look at. And since all the ocean activity will be conducted from the coast, so we need a planning, science-based planning of all different activities which we take on the coastal and marine, and how do we manage so that development is sustainable. So in India, we have a coastal regulation zone, which has 3 notifications, 91, 2011, and 19. And India is one of the very few countries in the world where the coastal zone management plans for the entire coast is available on a very high resolution. I mean, 1:25,000 scale. So this is extremely important, and this could be achieved because there was a large amount of people who have been now, each state has now understood the importance of the coastal zone management, and the plans have been made. So these are the kind of maps which has been produced for the entire country, and these maps are then converted into a coastal zone management maps. The other important aspect of the economic development that we need to identify which are the areas on the coast which are vulnerable. And fortunately, India has the complete understanding about the coastal vulnerability. The maps for the entire Indian coast is now available. It is very complex process by generating this coastal vulnerability index, but this has been done and the maps are available for everybody to see. And recently to develop the tourism, the certification process, that is a European Federation for Environmental Education, they give a certified if your beach has certain safety, the kind of condition of the beach, the water quality, the facilities on the beach, depending on all these aspects, the blue flag certification is given. And India has now joined. Already India has 8 beaches which has been certified as the blue flag beaches. Another 10 beaches has been submitted to FEE, and I understand by September we are likely to get another 10. The idea is that to develop about 100 beaches on the Indian coast, which are very safe, water quality is good, and all other facilities on the beach is available. So this could be another important area of economy where the high-end tourism can be developed. At the same time, when you want the understanding of the science is going to be always very critical. And if you don't do that, all the services and the benefits which we want will not sustain for a long time. So the second International Indian Ocean Expedition was launched in 2015 after considering, because the Indian Ocean, there are several issues which are yet to be understood about what its societal benefits and some of the science issues about the boundary canal dynamics, monsoon, ocean circulation, extreme events, and various biological, physical, biogeochemical processes. So there are a large number of projects, and the many countries have been involved in this, and India has taken a major initiative to push this, and this is now up to 2025. So I think will provide a lot of new information which will be coming from the Indian Ocean. We would be able to utilize for the economic benefit. And all this information, which is now being integrated as a digital ocean. So all heterogeneous data, I think this is something which is a classic, which has been done at MoES, that all the information, whatever available, you can put it the way, and you can retrieve in the way you want along a transect or in the 3D or a 4D or a point. So this is what I think is going to be very critical for us for the blue economy. And I think the most important is what I see is that the investment in ocean is going to increase. And we have seen that this year, the government of India has already declared a deep ocean mission to know about the resource, to build service and the technology. So that, and similar thing, I'm sure that will be continuing. Now, the most important is that the various scientific data which all of you are collecting, and also some of the environmental data. Now we have to learn to integrate this information along with the social and economic data. Because unless we do that, we won't be able to develop a system where we can say that protecting environment also makes an economic sense. So in the blue economy, I think this is the most important aspect, that we have to build a framework where we integrate the scientific data with the environmental, social, and the economic data. Then only what I said in the beginning, that the social inclusion and ensuring environmental and ecological security along with the economic development can happen. So to do this, we need an institutional framework and a policy. And if we can do this, I'm sure that ocean will provide a sustainable growth. Thank you very much for giving me this opportunity and accommodating me in the valedictory address. Thank you very much.